Big question किए बस
मैंने 66 किए
मैंने 63 कर दिया
मैंने 81 किया 91 बोला
अभी कर दे दो 3 कर दो इजी
अरे लेके आना सबको फोन में क्या है उसका नहीं होता है एक में 19 आया है और एक में 13 आया है शिट तेरा डायग्राम भी गलत था सबको बोलना अरे चेंज नहीं करते ये लोग मार्क्स मेरा 29 मुझे 18 बोला मेरा 29 करना ये 20 करना अरे तो हम कर सकते हैं चेंजिंग होता है उसका करता है मैंने 66 क्वेश्चंस किए 81 किए पागल है ये तो तुम सेट आउट के लिए सेट बना था भाई क्या काउंसलिंग दिक्कत होती है मैंने लड़की वाले ने किया हो गया लड़के वाले किया ओके अब स्टार्ट है नाटक तो करेंगे पता ही नहीं होगा क्यों ऑनलाइन करना है ऑनलाइन में तो काउंटिंग सबसे ज्यादा इन्वॉल्व मैं क्या बात है तो नाम मेरे पास है नहीं
तुम लोग को बायोलॉजी का टेस्ट भी मिल गया रिजल्ट
बायोलॉजी का नहीं करा केमिस्ट्री
अच्छा मुझे लगा मुझे नहीं मिला
तो क्या बोला नहीं आ गई एक उन्नीस आया हुआ एसिड बेस सॉल्ट
दोनों जहाँ तक मुझे पता है
देखो एसिड बेस में उन्नीस है बेस हो गई है कितना एसिड हाँ तो फिर क्या करना
Any questions over the I sat down yesterday and I was I did not touch the overnight. I was doing the projects and I was dying.
So how many
50 or something. I don't know.
how many pages you write this space only
Only 3 until now.
how much would it be objects
I can pay. Only 3 until
I questions like for any part of the human speaking
I'm written 50 pages in German.
50 pages for this detailed
Like 1 page, 2 pages, 3 pages. 5 0. I've written only 50 and history and obviously.
तो बोला है कि फैक्ट्री में तो नहीं काम करते नहीं बोलते थे सब लोग नहीं क्या भी बोला क्या है फिर क्या मैंने
तो सर 50 जगह पे एक साइड One plus 7 is square. One thing, one line for one. अरे भाई चैट जीपीटी को नहीं बोलना चाहिए सॉल्व करने के लिए आप
तो 16 पिक्चर का क्या चल रहा है चैट जीपीटी से क्या है मैंने चैट जीपीटी का नहीं वापस से फिर वहां से डाला वापस का चैट कर अभी नहीं
अलग अलग
जो पहले का आंसर क्या है
नहीं भी किया अगर नहीं भी किया 2 meters
What is the word?
किसने किसने किया है किसने नहीं किया होमवर्क क्यों पता नहीं था भूल गए मतलब कौन से क्लास में हो फीवर तुम मैनेज करो ठीक है आना नहीं चाहिए फीवर आगे से नहीं यू हैव टू टेक केयर ऑफ योरसेल्फ ये सब एक्सक्यूज में गिना जाएगा थिंक ऑफ मिलिट्री पीपल थिंक आज बुखार है जाएगा नहीं लड़ने के लिए ठीक है डोंट टेक योर लाइफ फॉर ग्रांटेड सो योर स्टूडेंट सो यू हैव टू टेक केयर ऑफ योर हेल्थ आल्सो दैट्स आल्सो योर रिस्पांसिबिलिटी ठीक है वायरल एंड ऑल इज ओके मतलब मेडिसिन लेके 2-3 दिन में ठीक हो जाएगा homework is a must we are meeting after 7 days you're here for 2 days what did you do rest of the 5 days how can you say you can't remember I speak in the class about homework were you present or not it should not happen next time sit there okay where did we stop last class everybody remember you're not small kids anymore just after this year you're going to get into 11th and 12th these small class tantrums won't do now कॉर्पोरेट में नहीं चलता है ये सब बीमार हो गए तो ये वो परफॉर्मेंस ठीक है टेकिंग केयर ऑफ योर हेल्थ इज योर रिस्पॉन्सिबिलिटी so I'll check the homework in last half an hour let's start the day where did we stop in the last class
application of the refraction of light
real depth completed
yes sir
did we discuss that
yes sir the diagram we wrote some notes or
you have completed when the stick is any stick is inserted into okay only real depth and all right do anybody has any question about what we did in the last class no okay so what we did is that apparent depth is smaller than the real depth and by how much by the refractive index of the medium right now what is the shift what is the shift it is d by t isn't it you remember the diagram so ये उड़ के आ रहा है एकदम पीछे बैठ जाओ वैसे भी पीछे ही बैठता है so this is now we saw that if you look at any point P at the base of the pool right So if somebody sees it from top, because of the refraction from the denser to rarer medium, so this point T is raised up till P dash. So the real depth was this much. This was the real depth. Capital D. Okay, and this point is the apparent depth. Small d. Again, this P is raised here. So what is the shift? Shift is real depth minus this apparent depth. Correct? So this is the shift. By how much distance the bottom has risen up? Okay, as seen by the viewer outside. So how much is this now? So d minus dy mu m. So this is d 1 minus 1 by mu m. So I think we did not do this in the last class. Did we do this in the last class? Okay, so this is the shift. Now there is another case for real and apparent depth. Right now, where is the observer? Outside. That is, observer is in the rarer medium. And this is the denser medium. Now switch the position of the observer. Now if the observer is inside and looking at things outside. So how will it appear? Will it appear taller? Let us say a tree is here. Will the tree appear taller or shorter to the observer who is looking at the tree from inside? Will appear taller, right? So can you all try and draw the ray diagram? Now keep the observer here. The object is placed outside. No. When the observer is in the denser medium, the object in rarer medium appear taller to you. Okay? So I want you to draw the ray diagram for this situation. Now the observer is inside. Let us say, I'll give you the situation like this. Imagine there is some tree outside, okay, and some fish is looking at the tree. Okay, who is the observer? Fish. Observer is fish. And this is the tree. Tree is the object. Okay. Now, if the fish is looking to this tree, draw the ray diagram showing that this tree will appear taller to the fish. Draw the ray diagram. Let's take the. Why is so late? And these excuses. Okay. 2 more days. I understand it was a tough one for everybody, right? But what is your school times? What is your school times? Regular school times?
7:40.
Exactly 10-15 minutes early. Anyway, 2 more days you have to stretch. Okay. After that, some relaxation. All right. So what is this? This point, the fish is observable. So what do you require? 2 rays, right? So 1 ray, let us say it's coming straight, or take 2 rays and draw the diagram. Let's say the 2 rays are coming like this. Then what happens? So you draw the normal. Okay, these are the point of incidence on the interface between the two mediums. So obviously it will bend towards the normal because it is now entering in the denser medium. So it will go towards like this. So and this will bend less. Both will bend. Okay. So slight bending is there. So now what you will do? You will stretch it backwards. So this the top of the tree K is now here, A dash. Right? So to the fish feels that tree is this long. This is the actual height. So sometimes you learn in one way, but when the question is asked, they will completely twist the scenario. So whenever the observer is in the denser medium, he will see objects in the rarer medium taller. And whenever the observer is in the rarer medium, he will see the objects inside the denser medium shorter. Okay. Right? We'll take one more application. I'll erase this now. We'll take the third application. There is a stick which is half inside the. Is the stick visible? Okay. When a stick is entered inside, so how will it appear to the observer outside? Huh? Bent where? Upward. Upward. Like how to draw the ray diagram? You can treat the bottom of the stick as let's say point P. So it has to rise up. Okay, somewhere here. So now draw the ray diagram. So for this point P, draw the ray diagram. You require two rays. Just like two rays from the top of the tree. Now the two rays will go out from here. Okay, then what happens? Observer is outside, stick is inside. Let me draw the arrow. The light ray. He is seeing, right? Light ray is coming towards the observer. Then this should be like this. Straight line. This is straight line. Just like this. Then we do it again. Look at the draw the diagram little bigger so that it is convenient to draw the rays. Leave some space. Then you get that one graph. You have to see the video. No, now he is seeing this point, right? So how do you see objects? The light ray has to travel from the object to the observer. तो यहाँ से नहीं आए, वो अंदर देखेगा. So you take the help of the light. Next. So anybody who misses lecture, please see videos and come. Otherwise, you will not connect. These are long duration lectures. A lot of motion is covered. Otherwise, mental torture for you. So the rays are coming from here. Then it suffers refraction. Did you attend? Did you attend the first lecture on refraction? Then you won't understand it. If you try to make sense. Anybody completed?
Almost.
What are you? As per your diagram, the state should bend or not. Where is your, this point has come here now. That's not bad. But see the diagram in the book. Point 3 draw two ways outside towards the road. So the light comes out, was normal, the point of the away from that certain way. Then this away, and that is stretched backward. That should come here. Okay, two ways. Opposite. Just see how all the diagram for three. Yes. But I don't think one is stream of this diagram. So medium change is taking place, right? The insert is error. So what will happen? At the point of incidence, if you draw normal, everybody draw normal at the point of incidence. जब वो डेंसर से एरर में जा रहा है, वो नॉर्मल से अवे जाएगा. हाँ, नॉर्मल से अवे जाएगा. मेरे हाथ तो होना तो सीधे निकल गया. डायरेक्शन चेंज होना चाहिए. करेक्ट. It is correct, but you've taken one straight ray. Both ray bend I want to. Then also you get. So one ray, let us say, goes here, bends, then you take it backwards. And the direction is wrong. Observer is here. So the light ray is coming from here to the observer. Correct. Yes. But this point This point should exactly come to okay. ये तुम्हारा ये ऐसे नहीं आएगा ऊपर उठेगा ऊपर नहीं थोड़ा सा ये पॉइंट ऊपर उठेगा whatever the other take one more way. This point should be exactly above this. Draw a bigger diagram otherwise नहीं है तरीके से आ गया पहले का ये चलो let me help you. Most of you are not getting it right. Only one person has got it right. Two person actually, but we staying in that direction. ऐसे नहीं देखो start from start. ठीक है what is the process of seeing an object? How do I see anybody? Okay, let's say I'm seeing this study abroad. So क्या हो रहा है? Study abroad पे light is falling. That light is reflected and coming to my eyes. That's how the image is formed. So what the observer is saying? Point P, which is the bottom of the stick. So the light has to travel to the observer, right? So पहले क्या हो रहा है? Let's say I draw this ray. So यहाँ पे क्या होगा? Normal. So medium changing. This is the point of incidence. So what should happen? It should go away from normal or towards the normal? Yes. What should happen? It should go away from normal or towards the normal? Away, because now the medium is changing. So away बनाओ उसको थोड़ा सा दूसरी तरफ. Okay, so it is slightly away, right? Take another point, another ray. Okay, slightly close. It should further go away only. What happened to the pen? It should go away only. So I have two rays that are going away. Now extend it backward. This is also extend backward. So where this point P is meeting? Now at P dash. So for every point, it will go up. Okay? Rays from every point will go up. So then what happens? All the portion of the stick which is inside water, it will proportionately rise up. Okay. So this is how the stick will appear bent. Okay, stick will appear bent. Is the diagram clearly visible from behind? I understand it is a small diagram, तो पूरे नहीं समझ में आ रहा है. जो भी ऊपर जाके at the point of incidence, it will go away, and then these 2 points. So manipulate your diagram. You actually make a point here. Then using point of incidence and this point, from these 2 points you can draw a straight line. Okay. Again from here you can draw a straight line, but the line within water should be dotted and outside should be solid. So find a way. You'll exactly get correct diagram. Is it understood or should I draw it big? So don't be lazy. If you feel that the diagram has not come out well, redraw it. देखो. Let us say this is the stick. This is my point. I know it has to come up. So this is my point P dash. बना लो पहले से. ठीक है. Now select 2 rays. So this is one point of incidence, this is another point of incidence, right? Select this point where it is supposed to get raised. Scale रखो, इस point को इस point से match करो. Okay. Then draw the line here. Understood the technique? Now join these 2 points. Like keep the scale aligning these 2 points. Draw a line here. Now extend it. Is this clear now? Wherever the scale will go up, वहां पे point बना लो पहले. Then using these 2 point of incidence and this point, the race point, वहां से line draw करो. बन गया. And then by logical deduction, join these points. यही से नीचे वाला भी join कर दो. So this is your scale now. ठीक है? This is all. Because for every point will proportionately go up. Is that clear? So this is why you draw the radar. Questions come to exactly draw the radar. That's why I'm making you do this. This will fall in application type. Okay, so with this we have completed what have we completed? We have completed simple applications of refraction of light, right? So there are certain consequences. There are other phenomena that take place due to refraction of light, right? Stars appear twinkling to you. That is due to, that is due to atmospheric refraction. This twinkling of star is just the impression. It's not that stars stops emitting light and then it's not like that. There is an apparent shift in the position of the star due to refraction. Okay, so that is twinkling of the star. Sun is seen few minutes before it rises. Do you have a textbook? In the textbook, just see the last article. Some consequences of the refraction of light. Just read through it. Can you get it? It's in C. 4C. 4C ka last. Yes. I can exactly show you how the star twinkles by making ray diagrams. I can show you Mirage by making ray diagrams. Can you visualize? Where is Mirage? It's not here. It will appear after we have completed critical angle and all. Mirage will not be here. Right now, it's only about refraction of light. So let me show you one how stars twinkle. That should give you the clue for the rest of it. Okay. Like last 2 points we already discussed here. What is the ray diagram for last 2 points? Like a tank appears shallow than its actual depth. So real depth, apparent depth we've already seen. A person's leg appear to be shorter when standing in a tank. When standing in a tank. ठीक है? मतलब stick ऊपर उठ रहा है. मतलब तुम भी अंदर जाओगे तो leg क्या होगा? ऊपर उठेगा मतलब legs will appear shorter. ठीक है? So last 2 points, is it clear? These are the ray diagrams for it. Now, a piece of paper stuck at the bottom of the glass slab appears to be raised when seen from above. Do you have a transparent paperweight at your home? Or any transparent block? Right? Let's say you keep the scale, thick scale, okay, or a slab on a piece of paper and some printing is there. That printed stuff will raise up. Okay, you can see that. So, and why? So everything raising up is this ray diagram. Okay, anything raising up. What you can do is, if you have a glass, transparent glass, fill it. Okay, let's say 1 inch. Now keep the glass on the printed star. You will see wherever the glass is there. Now see from the top. The printed stuff outside and what you're seeing through the glass will be difference. It will appear raised up. So you can actually do these things. Is it appearing raised up? Yes. See. So you have to just think of how you can do that. Right? What is the ray diagram for it? This is the ray diagram. मतलब जो point P नीचे से ऊपर गया, ठीक है? So the first two, I will show you the ray diagram for the first two. The twinkling of stars. So basically, an observer let us say the observer is watching stars from here. Right? Somebody is looking at star which is here. So what is this? Earth's atmosphere. This is Earth's atmosphere. What is this? Space. There is space here. And you have atmosphere. So what is atmosphere? It is the collection of gases which is envelop Earth. Right? So obviously, if you look at the density, it is denser medium. Denser. Okay, this is rarer medium. So when the light ray enters Earth's atmosphere, okay, then what about the density of the atmospheric layer? Atmosphere has different layers actually, with varying densities, right? Atmosphere does not have uniform density. It is more near the surface of Earth. As you go up, the density decreases. So the upper layer will bend the light, but not bend so much. It will bend it little. Then it will bend even more. And then finally it reaches me after a lot of bending. So it gets curved actually by the time it reaches the observer. Okay, straight, and then there is different bending taking place. Continuously it is bending now. So what is the last direction? He sees that the star is actually here. So this is the actual position of the star, and this is the apparent position. Okay. To the observer, star appears here. So when he is looking at the star, let us say his gaze is fixed in this direction. Right? But atmosphere is not like a glass prism. It is not a fixed environment. It's a dynamic environment. So it is the density keeps varying. Right? So sometimes, like there is air, etc. Right? So sometimes the density increases and sometimes it decreases. So when the density increases, the position changes again. But his gaze is fixed in one direction, right? So suddenly star disappears. Sometimes the star goes up from the apparent position, sometimes it goes down, depending upon how the density is varying. Okay, so this constant appearance and disappearance of the star gives the impression of twinkling of star. It's not that star, emits and stops emitting light. It's not like that. So this is phenomena due to atmospheric refraction, right? Same is applicable for early sunrise and delayed sunset. So when you see the sunrise, okay, the first sunrise that you see is an optical illusion. Sun has actually not risen. Okay, it's an early sunrise. Why is that? Look here. So let us say this is the horizon. Okay, this is the horizon. So obviously, if you want to see any object, it has to be above the horizon, right? So let's say sun is rising. It has not yet come above the horizon, but it is very close to horizon, right? So let us say the sunlight hits the atmosphere. So instead of going like this, now it suffers atmospheric refraction towards the observer and it bends like this. And therefore, what happens? Observer feels sun is here. Okay, sun is still below the horizon, but it appears to the observer that it has risen. Okay, so there is a gap of roughly about 2 minutes. After 2 minutes, there is an actual sunrise. So it is early sunrise. Right? Same thing happens at the sunset. Now the sun has already set, but you continue to see the sun. Okay, so that's delayed sunset. Early sunrise and delayed sunset. Right? So this discussion, ray diagram, etc., is given in NCRT, but it's not for you, so I thought I'll just give it to you as well. Okay. So read the consequences. Now, next chapter also, next topic also has some consequences. But before that, we'll start a new topic, which is called critical angle and total internal reflection. Lot of questions come from here. In optics, in this chapter, most questions come from here, critical angle and total internal reflection. Okay, so let us understand what is critical angle. Its symbol is C or IC. Okay. Any symbol you can use, critical angle. So far, we have studied the phenomena of refraction when light was traveling from a rarer to denser medium. So far, right? But now, let's flip it. So this is the phenomena associated, okay, when light is traveling from denser medium to rarer medium, right? So let us see what is the critical angle. We'll see it with the help of the illustration. Now consider a denser medium like this. Okay, so this is a denser medium. Imagine it is glass or water, anything. Okay, it's a denser medium. This is your rarer medium. Let's say this is air, this is water. Imagine the source of light is here. Let's call this as S. This is the source of light. So let's see what happens to the light emerging from this source. Consider one light going along the normal of this medium. Let's call this as AB. AB is the boundary of denser and rarer medium. AB is the interface. Let's take the second ray. So this is the point of incidence. What should happen to this ray? First ray will go undeviated because it is incident along the normal. Right? What happens to this? Go away from the normal. Right? Basic law of refraction. It will go away from the normal. So you have, let's say, angle of incidence I1 and this is R1. So what is the relation between I1 and R1? I1 is equal to R1. No, R refraction is going away, no? R1 is greater than I1, right? Refraction is greater than whenever light passes from denser to rarer medium, the angle of refraction will always be greater than angle of incidence. Okay? So let us increase the angle of incidence. Let us say the light is now incident at this point. Okay. straight. Again, the angle of refraction will be greater than I2. Now R2 will be greater than I2 because it is going away from the north. If we continue this pattern, right, there will be certain angle of incidence. Let us say this is now some angle of incidence. There will be some angle of incidence for which the angle of refraction will become 90 degrees. Correct? There will be some angle of incidence for which angle of refraction will become 90 degrees. Oh, wait, क्योंकि angle of incidence, whatever is the angle of incidence, angle of refraction is more than angle of incidence. Right? So then this angle we call critical angle. Okay, what is critical angle? It is the angle of incidence in the denser medium for which angle of refraction in the rarer medium becomes 90 degrees. Now the refracted ray grazes along the surface of the medium. Is that clear? So critical angle is a spatial angle of incidence in the denser medium for which the angle of refraction is 90 degrees. Is that clear? So write down what is critical angle. Angle IC is the angle of incidence in the denser medium plus that the angle of refraction in the rarer medium is 90 degrees. Okay, and when this phenomena happens, when light travels from when light travels from denser to rarer medium, okay, when light travels from denser to rarer medium, critical angle IC is the angle of incidence in the denser medium such that the angle of refraction in the rarer medium is 90 degrees. Okay. In this situation, the refracted ray grazes along the surface of the two mediums. Okay. So then, what happens if we increase the angle of incidence more than critical angle? Now, see. Now, when the angle of incidence is greater than the critical angle, so we have seen, so this was the limit. This is the last angle for which refraction is taking place. Now, the angle of refraction should be greater than 90 degrees. If you see the normal from outside. So now, the light is bounced back in the same medium. Okay. So now it is a total internal reflection. What happens now? What is called as total internal reflection now at this point. Or it is called in short TIR. Okay. So this is evident, right? Every time the angle of reflection is increasing. Now if it increases more than 90 degrees, it is bounced back in the same medium. Correct? So this is called total internal reflection. What is total internal reflection? Okay, so let's write down the conditions. What are the conditions for total internal reflection? First condition is light must travel from denser to rarer medium. Light must travel from denser to rarer medium. Second, what is the second thing? Now this angle will be equal to this angle. Laws of reflection will be applicable. Right? The angle of incidence in the denser medium must be angle of incidence in the denser medium must be greater than the critical angle. Okay. So we are seeing here three types of cases. Whenever light is traveling from denser to rarer medium, if the angle of incidence is less than critical angle, then refraction is taking place. So for how many rays, let us say I name the rays. A already we have done. So this is the normal, let us say. Normal. And we use P, Q, R, and S. So rays N, P, Q suffer refraction. N, P, Q, and R. So N is a special case, no deviation. So ray P, Q, R suffers refraction. Okay. At critical angle, this is also refraction, but a special case of refraction. But we don't call it refraction here. It is a case of refraction. Okay. So critical angle is the limit of refraction, right? Where the angle of refraction becomes 90 degrees. This ray is still in the rarer medium, but touching the surface. Okay, so these three cases are refraction. After critical angle, what we get is reflection. Is it similar to mirror? So whenever the angle is greater than critical angle, the denser medium becomes mirror. Okay. So it will now reflect light. But is the reflection same as mirror? No, this is 100% reflection. The total energy is reflected. So the image quality formed by total internal reflection will be much greater as compared to mirror. Because mirror will absorb some energy, right? But here it is total internal reflection. No energy is absorbed, no energy is lost. Okay, so we'll see that application. Right. So do you have any questions here?
So the angle I will always be equal to the angle of reflection.
Yes, that is law of reflection, right?
But how it works
How?
will.
Then if it is not, then is it reflection? If you are calling it reflection, the incidence has to be equal to angle of reflection. Isn't it? Let's call this R dash. If you are calling it reflection, what is the relation between incident ray and reflected ray? Angle of incidence has to be equal to angle of reflection. Then only we call it reflection. Yes? Why are you overwhelmed? What is bothering you?
Because after taking the critical angle, it will directly bend so much that
It is not bending so much. It is equally bending as this on the other side of the norm. It's not bending so much. Just that angle of incidence is greater than the critical angle. Is it hurting you that it bends so much? You are not bending. Okay. Understood? Yeah. Actually, you very cleverly twisted. You were involved in some mischief. And I spotted you. And you dragged me into questioning.
so that was a
Sure.
and
Okay. That was not a genuine question because you very well know what is reflection.
what actually
Okay. Genuineness granted. It was not a fake genuine, I don't know what. Okay. All right, let's go ahead. So any questions here? Okay. Genuineness. Wait. Written everybody. In this part of chapter, only concept will be understood is critical angle and total internal reflection. Next, I am going to teach you is the relation between critical angle and refractive index of the medium. Whatever is on the board right now. Close the textbooks. I will tell you when to open it. Close it. Open it only if you need help in diagram. You don't understand what is there on the board. See, these ray diagrams are not paintings. Okay? These are technical diagrams. And the arrow has to be there. There's no arrow here. Again. Before and after refraction. There should be direction. Before and after refraction. तुम अभी ऐसे ड्रॉ करते हो जो भी ये समझने के लिए you have to understand what are laws of refraction. वो तुमने मिस किया है वो laws of refraction वाला वीडियो देखो 2-3 वीडियो पहले के देखो समझ आए. I'll tell you in short what is refraction. देखो क्या होता है रिफ्लेक्शन तो पता है कभी भी जो एंगल ऑफ इंसिडेंस है रिफ्लेक्टेड रहेगा एंगल बराबर ही हो ठीक है. रिफ्रैक्शन क्या होता है whenever light passes from one transparent medium to other ठीक है. तो जो दूसरा मीडियम में जो लाइट जाती है ना तो वो सेम डायरेक्शन में नहीं है उसका डायरेक्शन चेंज होता है ठीक है. और वो डायरेक्शन कैसे चेंज होता है अब ये वाला मीडियम डेंसर है और ये क्या रेयर. व्हेन इट ट्रेवल्स फ्रॉम डेंसर टू रेयर तो नॉर्मल से दूर जाता है. क्यों? क्योंकि स्पीड डिफरेंट हो जाता है लाइट का. डेंसर मीडियम में स्पीड कम होता है रेयर में स्पीड बढ़ती है. यहां से निकलते टाइम सडनली स्पीड बढ़ती है ना तो नॉर्मल से दूर हुआ ठीक है. वही अगर उल्टा चलता समझ लाइट इज ट्रेवलिंग फ्रॉम एयर टू ग्लास या एयर टू वाटर अब यहाँ फास्ट चल रहा है, तो जैसे ही दूसरे मीडियम में घुसो स्लो हो गया, तो स्लो हो गया तो क्या होता है, वो नॉर्मल की तरफ बढ़ जाता है, स्लो होने की वजह से। ये रीजन है रिफ्रैक्शन ऑफ लाइट, ठीक है। तब उसमें रिफ्रैक्शन में बहुत सारे लॉज है। क्या लॉ है? एक तो ये है कि जो एंगल ऑफ इंसिडेंस है उसका साइन डिवाइड बाय एंगल ऑफ रिफ्रैक्शन, ये हमेशा कांस्टेंट होता है, ठीक है। एंगल ऑफ इंसिडेंस कहाँ पे है इस केस में? डेंसर मीडियम। और एंगल ऑफ रिफ्रैक्शन का है रेयर मीडियम है, तो दोनों अलग अलग मीडियम है। तो इस कांस्टेंट को कैसे लिखते हैं? 2 1 रिफ्रैक्टिव इंडेक्स ऑफ द सेकंड मीडियम विद रिस्पेक्ट टू फर्स्ट मीडियम। क्या बोलते हैं इसको? रिफ्रैक्टिव इंडेक्स ऑफ द सेकंड मीडियम विद रिस्पेक्ट टू फर्स्ट मीडियम। तो ये लॉ है, ठीक है। दिस इज कॉल्ड स्नेल्स लॉ। ये हमेशा जब भी रिफ्रैक्शन होता है तो ये लॉ ओबे होता है। जैसे रिफ्लेक्शन के लिए क्या लॉ था? एंगल आई इज इक्वल टू एंगल आर, वैसे ही रिफ्रैक्शन के लिए ये लॉ। और एक लॉ क्या है इसका? म्यू टू वन को क्या बोलते हैं? रिफ्रैक्टिव इंडेक्स ऑफ सेकंड मीडियम विथ रिस्पेक्ट टू फर्स्ट मीडियम, ठीक है। तो इसका और एक लॉ है और एक डेफिनेशन है। ये रेशियो ऑफ स्पीड ऑफ लाइट्स के फॉर्म में भी है। Refractive index of second medium with respect to first medium is given as ratio of speeds of light, ठीक है। तो जैसे ये फर्स्ट मीडियम अभी तुम्हारा एयर हो गया, इस केस में फर्स्ट मीडियम ग्लास है, ग्लास या वाटर, सेकंड मीडियम एयर। अब लाइट इधर से चलती तो ये फर्स्ट हो जाता, ये सेकंड हो जाता, ठीक है ना। तो ये दो फॉर्मूले हैं इसके रिफ्रैक्टिव इंडेक्स के। बाकी एब्सोल्यूट रिफ्रैक्टिव इंडेक्स, तीन चार और फॉर्मूले हैं, तो अभी इतने से तुम पहले पढ़ो, नेक्स्ट क्लास में मिलेंगे। बना लिया सबने डायग्राम? कैन आई इरेज इट एवरीबॉडी? Now relation between critical angle and the refractive index of medium. Critical angle. What is IC and what is mu? IC is critical angle and mu is the refractive index of the medium. So consider this diagram. So air, glass, or rarer and denser. तो इसका मीडियम क्या है? The RI of the medium is mu. Now let's say this is critical. So what have I shown you? The light is traveling from what to what? Center to rest, right? And it is, what is the angle of incidence? Which is critical angle. Angle of incidence is, and therefore what is the angle of refraction? 90 degree. Okay. So now I will apply Snell's law at O. Okay. So therefore, by Snell's law, apply the Snell's law at point of incidence. What will I get? Sin IC upon sin R is equal to, what do I get? What is the medium? 1, 2. A, M. So it is A, M, correct? First medium is written later. Second medium is written first. Correct? Isn't it? M लिखा है ना इसका refractor. I have given you. It could be glass or water, anything. Any tensile medium. ठीक है? Glass or water. So I am taking refractive index of the medium as M. Yes? Refractive index of the medium. Is that okay? Mu AM, everybody understood? So, can I write it as 1 upon mu MA? Can I write it as only mu M? Can I write it as only mu M? Because it is absolute refractive index. So I need not write A. Right? So what is this? This is now sin IC divided by sin 90. And sin 90 is 1. So what is this? Is the relation. Okay, what is the relation between critical angle and refractive index? This. So what do you get here? If the refractive index of the medium is more, critical angle is less. Is that clear? There is an inverse relation between critical angle and refractive index of the medium. Okay? Therefore, critical angle यहाँ पे तो मैं ऐसे भी लिख सकते हो decreases with rising okay? So we got this relation that critical angle decreases with rise in the refractive index of the medium. Okay? Right?
We can also recognize that as
That's you can write but not needed. Just keep it simple in sign. Okay. So this can be like what he's saying is 1 upon sin IC. Because in the book it is given 1 upon sin is cosec. ठीक है? जरूरत नहीं है उसकी. Just remember this. So what is IC? Then that becomes sin inverse 1 by m. That is mathematics, not physics. You should understand what is the relation between this and critical angle. Okay. This part is mathematics. Not interested that much in mathematics. What we are interested is what is the relation between the refractive index and the critical angle. So any medium with high refractive index, its critical angle will be less. So what is the medium with highest refractive index that you know? Diamond. So its critical angle will be least. Now you can open the book and see the table. They have given you critical angle for various substances. So for water it is about More than 42, I think. For glass, 42.
40 is
49.
1
Huh? 49. It will be greater than 42. Yeah. So water 49. Glass it is 42. Diamond it is roughly 24.
24 and a half.
Huh?
24 and a half.
24 and a half. Okay. So these are some values that you should remember. And how? This should give you the clue. Because now you remember the refractive index of these substances. What is the refractive index of air?
1.
One. Water?
Air 1.003. Go back to
1 mark is close. Air is 1. What is water? 1.33. Glass is 1.5. Diamond is nearly 2.4 or 2.5. Nearly 2.4. So just remember these approximate values. And critical angle के लिए उल्टा है. जिसका ज़्यादा refractive index है उसका critical angle कम है. Okay, did you get the table of critical angle and refractive index? What page it is on? What's the page?
101.
101 in the new book. Okay, page 101 in the new book. Right? So what is the factors on which critical angle depends on? Refractive index. So factors that affect critical angle. What are the factors that affect critical angle? One is refractive index, right? So one is refractive index of the medium or nature of substance of the medium. Okay. Second, it will get affected by what is it? Temperature. So actually, temperature is not a different thing. Temperature से basically refractive index change हो जाएगा. So indirectly these are one and the same. इसमें wavelength भी आ जाएगी. सब एक दूसरे से related है. उसमें अलग अलग लिखा हुआ है. So nature of substance and color of light. Okay. इसमें color आ जाएगा. यहाँ पे भी wavelength और color. बेसिकली क्रिटिकल एंगल का डिपेंडेंस किस पे है? रिफ्रैक्टिव इंडेक्स. जो जिस चीज से रिफ्रैक्टिव इंडेक्स चेंज होता है, टेम्परेचर हो गया, कलर ऑफ लाइट, वो सब अफेक्ट करेगा. अल्टीमेटली क्या है? रिफ्रैक्टिव इंडेक्स. ठीक है. तो टेम्परेचर का क्या इफेक्ट पड़ेगा? अगर हम टेम्परेचर बढ़ाएंगे तो क्या होना चाहिए? क्रिटिकल एंगल बढ़ना चाहिए या कम होना चाहिए? बढ़ना चाहिए. क्यों? रिफ्रैक्टिव इंडेक्स को डिक्रीज करता है. टेम्परेचर बढ़ाएंगे तो डेंसिटी कम होगी, मतलब रिफ्रैक्टिव इंडेक्स कम होगा. रिफ्रैक्टिव इंडेक्स कम होगा, क्रिटिकल एंगल बढ़ जाएगा. ऐसे वेवलेंथ से क्या रिलेशन? वेवलेंथ अगर बढ़ेगा तो क्या होना चाहिए? रिफ्रैक्टिव इंडेक्स कम होगा. रेड लाइट कम बेंड होती है, वेवलेंथ बढ़ेगा तो रिफ्रैक्टिव इंडेक्स कम हो जाएगा, तो फिर क्रिटिकल एंगल बढ़ जाएगा. यानी कौन से वाली कलर की लाइट का क्रिटिकल एंगल ज्यादा होगा? रेड का. रेड का यही है, ये रिवर्स रिलेशन. तुम पहले क्या करो, जो भी फैक्टर्स है उसका रिफ्रैक्टिव इंडेक्स के साथ रिलेशन निकालो, जो तुम्हें पता है। वेवलेंथ का उल्टा रिलेशन, टेम्परेचर का भी उल्टा रिलेशन है, तो क्रिटिकल एंगल के साथ सीधा रिलेशन है, डायरेक्ट प्रोपोर्शन है ना। तो तुम एक काम करो, उसको ऐसे लिखो, इसको तुम ऐसे लिखो, wavelength is inversely proportional to refractive index of the medium, therefore it is directly proportional to critical angle. समझ आए? Temperature is inversely proportional to, this is directly proportional to, यानी wavelength से critical angle सीधे affect होगा, direct proportion हो गया wavelength का और critical angle, ठीक है? You should build your logical relation. तो टेम्परेचर में और क्रिटिकल एंगल में डायरेक्ट रिलेशन, ठीक, क्योंकि यूएम के साथ उल्टा रिलेशन है, वेवलेंथ का भी टेम्परेचर। कैसे पढ़ना है इसको? वेवलेंथ इंक्रीजेस, ये डिक्रीज होगा, ये डिक्रीज होगा, है ना, ये डिक्रीज होगा, तो ये इंक्रीज होगा, ठीक है, ये लॉजिकल रिलेशन। All right, so we are done with this. Now we'll discuss application. ठीक है, application. Understood this much? Application stuff. Erase it.
Yes.
Applications of now we are going to study the applications of TIR in reflecting prism. So we are going to use three types of prism. Case 1, 45-degree, 90-degree, 45-degree prism. Okay. In this, the first application is deviation by 90-degree. We will use this prism to produce deviation by 90-degree. So this is our first prism. Now let us say we have an object here, calling it AB. So ray incident on face AB of the prism. So how is it incident on AB? What is the angle of incidence? 90. Angle of incidence is 90. It is along the normal. The angle of incidence is, so will it suffer deviation? No, it will enter straight. Angle of incidence is not 90, it is 0. Very common mistake. Okay. Now tell me, what is the angle of incidence on face AC? What is the angle of incidence? Huh? How to draw angle of incidence? We have to have a normal at the point of incidence. Where is the normal? This is the normal. So this is 90, this is 45. And normal makes 90 with the surface. So 90 minus 45 will be 45. Right? Angle of incidence is 45. And what is critical angle for glass? 42, you just saw. For glass, because this prism is glass prism, right? So critical angle is 42. What is the angle of incidence on surface AC? Greater than 42. So what will happen to the ray? TIR or refraction? TIR, because angle of incidence is greater than 42. It is greater than critical angle. Correct? So it will be reflected by 45 degree. So this is 45 degree. If this is 45, this is normal. So full 90 minus 45 is 45. This is anyway 45, so this must be 90 then. So this is incident along normal. So what should happen? What should happen on phase BC? Straight out, correct? Without deviation. Isn't it? So what was our objective? We wanted to obtain deviation by 90 degree. So with the help of TIR here, we have achieved this deviation. So how do you calculate the angle of deviation? This is TIR. So angle of deviation is in the output ray and the input ray. So if you extend this ray like this, the angle of deviation is 90 degree. This is the original ray and this is the emergent ray. So the deviation is 90 degree. This is what we wanted. Correct? So if you take one more ray from here, if you take one more ray from here, again it will suffer same thing. This is B. So this object AB is now appearing like this. So we are getting 90 degree deviation. Where is this kind of reflection of prism used?
Periscope.
Yeah, it is used for building periscopes. Used in periscopes. You have built periscope using mirror inclined at 42, 45 degree. Two mirrors. You haven't? Not in your schools? Okay. But everybody is familiar what is periscope?
Yes.
Okay. So you can go home and watch it in YouTube. So basically, what is the periscope? See, let us say now, if you keep the prisms like this, okay, so a ray coming from here, a set of two prisms aligned at 45 degrees like this, okay, so not 45 degrees, kept like this, right? So you can actually obtain a periscope that will help you view objects like it is used in marines, submarines, right? Submarine is underwater, and if the captain of the submarine wants to see any threat nearby, so he'll just pop out his periscope and will be able to see the enemy. Okay. So why use reflecting prism when it can be made using a mirror also? Let us say you have two mirrors. Exactly. So you can have two mirrors also, na? Yes, the image quality in the mirror will not be that high. The prism will give you very high quality image. Okay, that's why these periscopes will be costlier as well. In your childhood, you must have done it in your school projects. Probably you will remember. Yeah, exactly.
That's what I mean.
But we did it in our childhood. We also made the kaleidoscope.
Made kaleidoscope.
Kaleidoscope, you made. So you made something more
You
difficult.
made something more useless and
It's not useless. Fractals. So kaleidoscope, it produces designs. And those designs gives clue to these bedsheet printer, this modern art, to the clue, because in one kaleidoscope, you change the orientation, you get a different design. That can be, captured on a computer screen. And then stencils can be made out of it. Very different design. So it's very, very practical. It has a practical use. Right? Is this clear now? Right? So this is deviation by 90 degree. How to calculate the angle of deviation? What is to be learned here is that the different orientation of the prism and with different types of TIR, we can produce different deviation angles. How to measure the deviation angle? It is the angle between the incident ray and the emergent ray. This is the funda. Okay, so if you have understood this, the rest of the cases will be able to understand very quickly. Any doubt, anybody here? How TIR is taking place here? And why there is no deviation on base AB and BC? Because it is incident at 0 degree. So it is satisfying condition for no deviation here. But here it is satisfying TIR. Okay, ray is traveling. What is the condition for TIR? Ray traveling from denser to rarer. Denser to rarer. And the angle of incidence is greater than critical angle. Two conditions are satisfied. Okay, that's why TIR. Clear? What are the two conditions? Ray traveling from denser to rarer at this space. And the angle of incidence at this space is greater than critical angle. Okay? So everybody draw this. Drawn already? It is. Go ahead. Let us see the next case. Next case is deviation by 180 degree. And this is used in binoculars. What is the spelling of binoculars?
B-I-N-O-C-U-L.
Binoculars. Is this correct?
Yes.
Yes.
After that, and then wise.
Okay. So let's see how to use prism in constructing binoculars. Here also, what is the prism we are using? 45, 90, 45. Now what we are doing is, we are inserting the ray from its hypotenuse wala side. This is what is happening. Correct? So what is happening here? So this is now 90. Obviously, then the angle of incidence, by the same logic as the previous diagram, you will have TIR taking place here, as well as TIR here. So in your diagram, you have to mention where TIR is taking place. Okay. So is the angle of deviation 180 degree here? What is the incident direction? What is the final emergent direction? So incident direction is up and emergent direction is down. What's the angle between the two? 180, right? So it's 180, up, down. How do you construct a binocular now? So you have to use a pair of this. So what do? You have this. So from remote object, the rays will go like this. So this is just one cylinder of the binocular. So use a pair of these prism. So by 180 degree reflection, you can use this, right? So likewise, we'll see more cases once I come back. तेरे पास बनने हैं
अबे उधर बोला है क्या है क्या है बंद कर दो बंद है कोई ना इसको कोई
अभी साइंटिफिक नेम बताओ ना सार क्या होएगा प्रिंसिपल का इटालियन ब्रेन लॉस का Your markets तेरा नहीं है ना वही मैं भी बोल रहा हूँ ये हमारा डेविएशन है ये पूरी फिजिक्स ये तो ये पढ़ते हैं और हम लोग करके इलेक्ट्रिसिटी ये सब हमारे दो हमारे से तीन या इस मार्शल मैं निकालता नहीं हूँ अपने बैग से ये मैथ्स का ये टेक्स्ट बुक है फायदा एग्जैक्टली मैथ्स का टेक्स्ट बुक अबे तुझसे हो जाएगा मैं तुझे अच्छा मैथ्स है ये मैं तुझे इसको ये क्वेश्चन है अबे तो देख हमारे पता है हिस्ट्री में वर्ल्ड वॉर 1 है 9 चैप्टर्स इंडियन हिस्ट्री 9 चैप्टर्स इंडियन हिस्ट्री में तो इमेज करते हैं पीडीएफ नहीं और टाइम लगा 300 पेज का ऑलमोस्ट पूरा फिर 6 चैप्टर्स कंटेम्पररी वर्ल्ड हिस्ट्री फर्स्ट वर्ल्ड वॉर सेकंड वर्ल्ड वॉर राइज ऑफ डिक्टेटरशिप्स फिर यूएन हम लोग और 5 चैप्टर्स almost 20 chapters इंडस्ट्रीज हमें इंडस्ट्रीज हमें भी है मैन्युफैक्चरिंग इंडस्ट्री नहीं बोलिए ना आपको तो 3 टाइप की इंडस्ट्री बस इतना है इंडस्ट्री का क्या स्टूडेंट्स दे आर दे हां हार्ड इट्स अबे अरे यार इसके जो ना पेपर काम कर रहे हां ये क्लासमेट है पूरा ना इधर मेरा टीममेट है और पीजी हमारे ऑप्शनल भी है तुम लोग का ऑप्शन है बस हम लोग का हाइट ही होगा हम लोग का ऑप्शन है कि हम लोग लेके आते हैं तुम लोग का हाइट है इंफॉर्मेशन टेक्नोलॉजी है रोबोटिक्स स्टार्ट होगा व्हाट इज हम लोग का अभी हमारे आईसीएसई में भी रोबोटिक्स इंट्रोड्यूस हो गया अबे हो गया हमारे स्कूल से देख रोबोटिक्स आईटी हुआ कंप्यूटर हुआ पाइथन हुआ और तूने उसे लास्ट क्लास तेरे पाइथन के बारे में हां रोबोटिक्स पढ़ाते हैं एक महीना आया उसे तुझ पे आ अब रोबोटिक्स से अभी आ तो आई थिंक बोर्ड में आप सभी चालू करो रोबोटिक्स और फिर दिलान में हमारे स्कूल में आएगा बस बनाया यूजर का तो रिकॉर्ड डाल दो अबे नहीं एक्चुअल में उसने बहुत पैसा खर्च किया और उसको एयरलाइंस से परमिशन लेनी पड़ी थी ये रोड लाइक डबल डाटा विशेष में वो भी यार ये सिविल और एयर स्पेस होगा ऐसे लॉन्चर रॉकेट थोड़ा सा रॉकेट कैसे ट्रेन करते हैं और उसका आकर्षण था हमें पता है रिप्रोडक्टिव सिस्टम है पता है विजुअली हां पिक्चर और ये भी उसके अभी क्वांटम की बता सकते हैं डेफिनेशन इसको कर सकते हैं व्हाट इज द क्वांटम हमें से मोटा बनते हैं आई सब कुछ करता है सब भाई दूसरे लोग तो 4 पॉइंट्स ही दे देंगे हमें हमें पता है ये में सबसे अच्छा दिखता है ना बहुत ना ज्यादा अच्छा दिखता है ये ना मुझे दोनों भाई मैं ऐसे में से बहुत अच्छा दिखता है ये स्कूल का वो है लेगा है एक क्या हुआ था भाई एक लड़की मेरे पीछे पड़ गई थी आई वाज वेरी ट्रेंडिंग और मैं बोला आपने देखा ना भाई ये ना भाई ये बात सबसे ये वो टॉपिक नहीं कर भाई तो बुरा वाला भी भाई बाद में समझ रहा देख इधर फ्रेंड्स का भाई क्या फाइनल कितना कैसे काम करता है लेंस नेट से आया पर कभी तूने कभी ऑथेंटिक है कश्मीरी पंडित देखा है ये देख उधर उधर ऑथेंटिक है और वो अंडा खा रहा है आज एक बार पेट सिस्टम का एक सॉन्ग है मेरे पास और मैं ये सब करता है वैसे तो मैंने स्लैब का रिप्रोडक्टिव सिस्टम क्या मैं ये का पढ़ना ये नहीं जाएंगे ये नामरे पढ़ना मैं चेक का कैसे का कोर्स था पर मैंने नाइट में कमर्शियल लिया था तुझे याद है ना वापस कमर्शियल एप्लीकेशन फिर बाद में मैंने चेंज कर दिया टेंथ की लिए बहुत नाम जल्दी था उसका सिलेबस कोई कॉमर्स है भाई मार्केटिंग फिर भी ही ले लिया भाई पता है क्या करता है तो आपके में 4 बार पी होता है और हॉबीज ना कैसे हॉबीज में तुम लोग हॉबीज में अपन लोग चेस खेलते हैं पढ़ने नहीं होता हमको वो पी में मिलते हैं हमें एक पीरियड मिलता है हमें एक पीरियड नहीं मिलता हम लोग और कंप्यूटर नहीं जाना चाहिए था मुश्किल से सिर्फ दूसरा शटल को हमने क्या नहीं जानना तेरा तो भयंकर ये हॉबीज का में करते हैं पीए में पता क्या है पहला चैप्टर है ह्यूमन ग्रोथ एंड डेवलपमेंट एडल्टहुड क्या होता है चाइल्डहुड क्या होता है स्टडी पी यस पी हॉबी में पी पढ़ना पड़ेगा और आपको पता है क्या हमें 2 पीरियड फिजिकल करवाते हैं और 2 पीरियड वो सिखाते हैं 4 पीरियड है हमारा वे नो टैekwondo के बाद में टैekwondo का तैयारी सुन ये क्या होता है ह्यूमन ग्रोथ हो गया फिर बाद में फिजिकल एजुकेशन फिजिकल एजुकेशन तो खाली क्या है क्या खाए थे एक तो कुछ ड्रिंक्स ना मुझे इतना याद है और एक स्ट्रॉबेरी मोजितो था हम लोग को पता है टाइम मिला था बेकार नहीं अच्छा है अच्छा आई थिंक एक बर्गर था बर्गर चिप्स और एक कुछ तो भी ब्राउन अबे तुम्हारा नाम ही नहीं पूछा इसका नाम माउली है मराठी Maharashtra, Kashmir.
No, no, carry on, carry on. Everybody, take out your homework notebooks. I'll be there.
Vai ter essa obesity que eles estão per capita नीचे गया तो per capita भी पता नहीं होगा क्या होगा
जब तक मैं उठूंगा नहीं
तो the point now like which are friends के लिए लड़की की शिल्पा कोई तो भी
क्या
हाँ चलेगा. I have known first about where you do, what you must do. That's right. Welcome. Why are you not coming regularly? Is this that you don't like physics? You don't like the physics teacher? What is it? Yeah, your friend told me about it, but she also gave me health problems. Guys, you got to different, okay. Okay, yours was like routine and she has some of that. Okay, chalo, so do the most of it. Okay, okay, I'm sorry, I'm getting into a wrong area. But okay, what I mean to say is general health, sardi, जुकाम, बुखार जो है ना, that is not a health issue. Okay, वो एक routine issue हो गया है अभी. So you have to like manage. Now we are past Corona days and it's lurking again. Yes. So you go back home every night, please everybody start this practice of taking steam before sleep. 1-2 minutes steam लेके सो. अभी से करो.
but shall I wear my mask
You know, wearing mask is not okay. How many of you feel, I need to take your opinion, right? How many of you feel like wearing mask really helps? Personal opinion.
I think it helps so I wore a mask for a year and 7 days later
मुझे क्या लगता है 5%, I may be wrong, but if you wear mask, it multiplies your own thing inside. At least the immunity is maintained when you are exposed to the outer world. What say? Immunity is maintained when you are exposed to the outside.
that's fine.
There it is. And if somebody infected is sitting near you, that also a little bit. I don't understand biology. I am not a bio person, so I don't understand. Yes. All right, Bata, खड़े हो जाओ. How many questions? Come here, let him come outside. Okay, so first of all, give me a feedback. 10 questions a day Is it a very big task? And that too, those questions of your choice. Any 10 questions, even it is MCQ 10 question, I'm okay. Every day 10 questions, but some students are doing more MCQs.
I did it in order, but that's why.
Your turn will come. Please wait for your turn. Why you have not written date? Everybody is supposed to write date. That day's 10 question. Date wise, I want. ठीक है? So, ठीक है, तुमने question किया है, but you also need to be disciplined. Do it in a proper, appropriate way. How do I know तूने एक ही दिन में सब किया है कि daily किया है कि daily date 10 questions per day. ठीक है? तो ये भी नहीं चलेगा कि आपने एक ही दिन में 30 कर दिए फिर 2 दिन आराम करो, ऐसा नहीं. Set build the discipline, है ना? 10 question रोज करो and you will see the benefit. एक महीने के बाद देखना क्या होता है. बता कहीं पे तो कोई डाउट आया किसी क्वेश्चन में? ये क्या किए तो ये क्या? What is the question or what have you done? क्या पूछा था इसमें? Okay. ठीक है, fix header axis and it is free body. दो पे होगा, है ना? हाँ, एक fix में ही rotation होगा. ठीक है, कहीं डाउट आया तुझे? क्या देखा क्वेश्चन एक वॉल्यूम में किसी क्वेश्चन में यू विल फाइंड दैट इट इज आउट ऑफ सिलेबस. मशीन में एक आध क्वेश्चन ऐसे है, इंक्लाइन प्लेन वाला क्वेश्चन है, वो इंक्लाइन प्लेन वाला क्वेश्चन तुम्हारे सिलेबस में नहीं है, उसको तुम स्किप कर सकते. मैकेनिकल एडवांटेज ऑफ इंक्लाइन प्लेन नहीं है, तुम वो क्वेश्चन नहीं बनेगा. Pivoted at zero market. Weight 10 gram force. Pivoted is the what moment about differential curve. How can it be made horizontal? अरे यार ये तुमने क्लास में किया क्वेश्चन. नहीं, zero. ये नहीं, ये देखो ये नहीं ऐसा है, ये देखो ऐसा है ना, तो यहाँ पे वेट आएगा, तो मोमेंट क्या होगा, इसका वेट की वजह से क्या होगा. अब वो लेफ्ट क्वेश्चन में पूछ रहा है कितना फोर्स लगाएगा तुमने, तो यही लगाना पड़ेगा इस फोर्स के लिए, और एकदम ये पे लगाना पड़ेगा. वही निकाल और नेक्स्ट what are ready? Fire. So you also not कहाँ से शुरू किया? Doing like this. हाँ? You have to go like this. So again a feedback, write date and 10 questions. Date wise. Will be statistic for you. The collection of questions in volume is very good, especially the application type. Okay? Face any difficulty, anything in the class, the way I need to improve my teaching in terms of concepts, etc. Helping you. Total how many questions were there? तो एक दिन में 10 ही करते हैं. So, but when you miss that day, okay, if it is not the last day, backlog, try to maintain. Next week. Okay, I'll come to you, sir. That was it. How many questions you put still on? I think 16. The first one. Got it. If you're writing the answers, you don't write the questions. Just answer is enough. And you should know the question is on what page. So for your reference, you write date and you also write the page number. Okay, date and the page number on the top. जो भी questions तुम solve कर रहे हो, date and the page number. So that when you do like when you're talking to me, you don't waste time. ठीक है? ये सब करो. You face any difficulty?
No, sir, I had asked that day only for the and this.
Last work and homework notebook would be same. I don't mind that. Okay?
There was a question for explaining sentence ruler and sentence codes.
We'll discuss.
I don't know how to that.
Centrifugal is different. Okay, every day 10 questions you are getting.
So one day I've that's like 65. That's why I said 50.
But try it. वो तुम्हारा habit हो जाएगा.
With the math,
Just try 10 questions per day. What about you? You're not done. एक भी नहीं किया. Why? Last work में तो I do questions yeah for you. Very so that will not work. It will make your life difficult later on. अभी से करो. Maths or physics. You cannot afford to not practice maths and physics. ठीक है? Every day 10 question करो. तो ही तुम easily attempt कर पाओगे. Now the paper pattern is application oriented. Unless you are comfortable solving numerical, paper नहीं बनेगा तुमसे. हर दिन 10 क्वेश्चन करने हैं. ठीक है? वॉल्यूम से करो. टेक्स्ट बुक के शॉर्ट एग्जांपल्स पढ़ो. है ना? टेक्स्ट बुक के क्वेश्चंस पढ़ लो शॉर्ट एग्जांपल, फिर वॉल्यूम लगाओ. क्लास में तो मैं डिस्कस करता ही हूं. ठीक है ना? तो आऊंगा मैं तेरे पास. क्लास वर्क जो मैं कराता हूँ उसके अलावा जो टेक्स्ट बुक के शॉर्ट एग्जांपल्स हैं वो पढ़ो. There is no homework. See, I meet you once in 7 days. ठीक है? तो तुम्हारे पास बहुत टाइम है करने के लिए. Don't tell me अगर टाइम नहीं मिला. बीमार हो गए ये सब मैं नहीं सोऊंगा आगे से. बीमार नहीं पड़ना है. Give yourself command. I will not fall sick and you will not fall sick. ठीक है? Auto suggestion command ये सब practice करो लाइफ में. It works. It really works. Trust me. When the vacation got started, on the very first day, I suffered this influenza. बुखार आ गया मेरे को. कल से 9 घंटे लेक्चर लेना. We come here at 7:30. Our day finishes at 6 o'clock. 9 घंटा बात करना है. First day, this happened to me. What do? First day, steam किया, protein खाया, and then I said नहीं, nothing doing. No leave. अगर मैं एक दिन का लीव लेता हूँ, पूरा टाइम टेबल का वाट लगेगा. At the last moment, there is no faculty to replace. So if any teacher goes, it is very difficult to replace him. Suddenly, तुम देख रहे होगे chemistry में क्या होता है. Are you facing that? Some lectures are cancelled. Teacher ही मिल रहे हैं उसको rotate करने के लिए. एक 2 दिन में आया था extra. But 9 hours to find a replacement faculty very difficult. So you have to be at the best of your level. Hence you cannot afford. ठीक है? मैं बार-बार बोल रहा हूँ. 10 question per day rule homework वो है. वॉल्यूम ऐसे करना है. डेट लिखना है और ऊपर पेज नंबर लिखना है. वो क्वेश्चन कौन से पेज का है. And you can quickly ask me when in doubt. ठीक है? तुम्हारा तो नहीं है. तुम्हें पता था होमवर्क है अभी. फोड़ दो फिर. हाँ? किया करते किया कि नहीं? जितना किया नहीं किया, याद नहीं है मतलब कुछ नहीं है। देखो तुम्हें क्या करना है, मैंने अभी समझ में आ गया क्या करना है। डेट एंड पेज नंबर 10 क्वेश्चन एवरी डे, ठीक है। आई रिपीट दिस विद एवरी स्टूडेंट। तो ये नहीं बोले कि हमें पता नहीं था, मालूम नहीं था, भूल गए, नहीं चलेगा ये, ठीक है। कोई डेट नहीं लिखा, उसी को क्या मतलब विदाउट डेट देयर इज अ रेफरेंस। अभी तो लिख कम से कम
What does the video go?
ऐसे नहीं किया होगा। एक साथ ऊपर हीरो कर दो, 10 सेशन करते जाओ, डेली टारगेट पूरा कर दो। मतलब you will yourself relax, रोज करोगे,
बहुत सारा स्पेस है।
कितने ये बोलोगे? ये फर्स्ट टाइम मैं देख रहा हूँ,
अंडरस्टैंडिंग हो गई
मम्मी को आने के सामने एक साल के अंदर कहाँ है तेरा परफॉर्मेंस? लड़कों को मारना बंद कर दो, ठीक है। हमारे बच्चे इतने दहशत में थे, पीछे बैठकर शुरू करते हैं। टाइम पे नहीं आता है, ऐसी चुनाई तो मत घर पे आगे क्या कर रहा था आपको? कौन सा प्रोजेक्ट? हिस्ट्री के प्रोजेक्ट में रात हो गई कभी नहीं मिलेगा, उन लोग का जरा रिस्पॉन्सिबल हो गया। पेशेंट वेट कर रहा है, डॉक्टर पहुंचे नहीं, पेशेंट मर गया, डॉक्टर लेट हो गया, चलेगा क्या ऐसा? टाइम लाइन शेड्यूल डेट ये सब पंक्चुअलिटी बहुत मैटर करता है, ठीक है। कम राइट टू कम हियर बिफोर टाइम। आज मुझे पहले का प्लान बनाओ ना, पहले कितने क्वेश्चन की ठीक है, चल जाएगा। 50 से ऊपर होने चाहिए किसी वीक में। क्या सर ये ऐसा ऐसा सॉरी टेस्ट नहीं करेगा ये फिजिक्स की बुक और नोटबुक साथ में लेके जाएगा, सबके होमवर्क का बस सबकी वीडियो बनेगी। कौन सा एक मिनट किया that's what I was बहुत खराब है और इसको क्या बोलते हैं, डाउट क्या होता है? क्वेश्चंस कर आपने नहीं किया क्या? क्लास में बोला है अगर कुछ हो गया और कितने क्वेश्चन Every day does this question. How many people? But it's all about concepts. I'll just say, what you. I just want मार्क 1 जो है फ्रिक्शनलेस है, मार्क 2 इज रफ, ठीक है। क्वेश्चन ही नहीं लिख रहा है, अब जैसे क्वेश्चन ही नहीं लिख रहा है। वर्क पावर एनर्जी, ये क्वेश्चन किसने किया है? पेज 30, वर्क पावर एनर्जी पेज 30, क्वेश्चन 3, इसमें तो क्वेश्चन ही नहीं दिख रहा, ठीक है। तो ऐसा हो सकता है स्टूडेंट कुछ पार्ट रह गया हो कि उसका कोई डायग्राम हो, तो वैसे क्वेश्चन तो छोड़ सकते हैं, ठीक है ना।
इसके नीचे
नहीं, वो उसके नीचे उसके सब क्वेश्चन, तो कोई अगर ऐसा कुछ ये वॉल्यूम में मिल सकता है, जो भी क्वेश्चन तुम्हें एमबीबीएस लग रहा है तो स्किप करो, बहुत क्वेश्चन।
मैंने उसको बैलेंस में सर के क्वेश्चन दिया है।
क्वेश्चन 3 का क्या क्वेश्चन का कुछ मिसिंग है इसमें?
पर वाला क्वेश्चन है
क्या?
जो मेन क्वेश्चन होता है ना,
हाँ वही तो उसका वो क्वेश्चन मिसिंग है, तो वैसे छोड़ दो, ऐसा चलेगा। ओके,
इधर एक डिस्क्रिप्शन दिया है और इधर ही तो डिस्क्रिप्शन दिया है।
अरे वो तो इधर का क्वेश्चन, वो थर्ड टाइम और question is, everybody listen up. Question is, why? This is the question on page 37, question number 7. Page 37, question 7. Everybody read this question. Is it possible that no transfer of energy may take place even when a force is applied to a body? Is it possible? Yes, possible. Transfer of energy कब होता है? जब work होता है. Is it possible the force is applied and work is not done?
Yes sir, it is possible.
Right now, जहाँ पे एनर्जी बोल रहा है वहां पे वर्क के हिसाब से सोचो ना, फोर्स लग रहा है लेकिन वर्क नहीं हो रहा, तो नो एनर्जी इज ट्रांसफर्ड। अंडरस्टूड दैट सेंस? यस पॉसिबल, इट्स ए नो वर्क डन सिचुएशन, ठीक है। तो यहाँ पे क्या हो रहा है, इज इट नॉट ट्रांसफर्ड इक्विपमेंट फोर्स जनरेटेड फोर्स पुशिंग वर्क एंड एनर्जी दोनों हिसाब से सोचा है, एनर्जी का कुछ नहीं पूछ रहा है, कंफ्यूज हो वर्क के हिसाब से, ठीक है। Okay, let's proceed now. So the second example was deviation by 180 degree, and where do we use it? In binoculars. Third application. This was second application. Okay, this was second. Case 1, second application. Now we'll do case 3. Case 1, third application. Third application is inversion of image without deviation. Inversion of image without deviation. Okay, okay. Little later. Come back. Inversion of image without deviation. तो देखो इसमें क्या हो रहा है, ठीक है। अभी मेरे को क्या करना है, जो इमेज ऐसा उल्टा दिख रहा है, आई वांट टू मेक इट अपराइट, है ना, इनवर्ट द इमेज, ठीक है। तो उसके लिए मैं क्या करूंगा, देखो Now it is entering the denser medium. It will suffer refraction. ठीक है, तो ये क्या होगा अभी? ऐसे बोलो। कौन है ये? क्या चल रहा है? Maybe. So what is the direction of incident ray? Left to right. What is the direction of emergent ray? Left to right. So there is no deviation. There is no deviation, right? Both are in the same direction. Both are in the same direction. So there is no deviation. But now what is happening? The image which was like upside down, outside is upright. Okay. This is. So where will it be used? Used in slide projector. Okay. So in old days, these slide projectors were used. We don't use it anymore, or maybe only doctors when they are seeing the images, okay, like X-ray. So they might just project it. So some device will just invert the image, right? कभी-कभी जब जैसे convex lens का image कैसा बनता है? Real and inverted. So to flip that image up, that output is passed here through a 45, 90, 45 reflecting prism. This is also 90. This is 45. Yes. If the object is no, same thing. For this orient is same thing. This is 90, 45, 45. ठीक है? वैसे रहेगा. I mean, we have to place the prism such that these rays are incident on face AB. Then only we'll get output like this. Is that clear? Then, so case 1 is over. So all the cases with 45, 90, 45 prism, there are 3 cases. 3. And we have understood it. Okay, next is case 2. We want to now produce deviation by 60 degree. And for this we will use equilateral prism. Deviation by 60 degree by using equilateral prism. So what is equilateral prism? Where all angles are 60 degree. So let's draw the diagram. Draw the prism slightly bigger. The side of the prism should be at least 5 centimeters. Okay, so then you will get nice diagram. Okay. Now input the ray on face AB. now you have to input it. You have to input it along the normal. Now tell me, will TIR happen here on face AC? Yes. TIR will happen on face AC at this point. Yes or no? Tell me what is the angle of incidence here? What is the angle of incidence? This is 90, this is 60, so this must be 30. Is the angle of incidence 30 degree? No. What is it? 60 degree, right? Angle of incidence is 60. Okay. Everybody understood how the angle of incidence is 60? Because the normal on face AC makes 90 degree and this is 60 equilateral. This is 90 ray incident normally. So the balance angle has to be complementary, right? 60 plus 30 because this is 90, total 180. Everybody understood how this angle of incidence is 60? Understood? No? What is the property of triangle? Sum of all the angles of the triangle is 180. So when I make this ray incident here, right? So it is incident along the normal. So it won't deviate, it will come straight, right? So this is 60 equilateral. This is normal 90. So this must be angle when added to 60 should give 90. 60 plus 30. Now what is angle of incidence? It is the balance of the normal. 90 minus 30 will be 60. So what should happen here? Refraction or TIR? At this point, refraction, right? What is the critical angle of prism? 42. And what is the angle of incidence? Greater than critical angle. So what should happen? TIR. 60 is greater than 42. So it will suffer TIR. Correct? So now, what is this? This should be 60. If this is 60, right? This is 30. Has to be okay. 60, 30, symmetry. 60, 30. So, and this is 60. So this must be 90. Correct? तो ये क्या होगा? बाहर निकला है. Now what is the angle of deviation? What is the angle of deviation? So what is the original ray? Original ray was this. Right? So if you see this dotted line and this, so this must be 30. So what is the total angle of deviation? 60 degree. What is the total angle of deviation? 60 degree. Everybody understood how it is 60? देखो ये वाला एंगल कितना है? This is 30 degree. है ना? So this is original ray, incident ray. This is 60. So this 30 plus 30, 60. Yeah, this 30 and this 30 are vertically opposite. When I extend this original direction. So ये 30 और ये वाला भी 30 था. 30 plus 30, 60. है ना? So now we know that certain deviation can be used in certain application. अभी application नहीं पढ़ना हमको इसका. खाली deviation of 60 degree. ठीक है? So it might be used in some application, right? Okay, in camera, telescope, wherever might be used. ठीक है? But अब इसका application नहीं पढ़ना, खाली deviation. Next, deviation less than 60 degree. So now we'll be only learning how to produce a required deviation. Next application is deviation less than 60 degree. This is case 3 now. Using 30, 90, 60 degree prism. What are we going to use now for deviation less than 60 degree? 30, 90 and 60 degree prism. So how this prism looks like? Okay. Deviation less than 60. So anybody has doubt in this case? Case 2? Anybody has doubt here? Deviation by 60 degree? No. So let's understand this. So here we are inputting the ray from side BC. Okay. So let us say the ray is inputted like this. So by now you must have realized all the input rays are making angle of incidence 0. And therefore it is entering the prism without deviation. Now what happens at this surface? So this is 60, this is 90. Therefore this must be 30. Complementary angles. Correct? If this is 30, then this must be 60. Now this is greater than critical angle. It will suffer TIR. So if you make a 60 degree from here, it will hit somewhere here. So if this is 60, this must be 30 then. Right? And here there is normal. Okay. So if this is normal, you extend the normal. This is 90. And this must be 60 then. Then this must be 120. So 120 plus 30, 150, then this must be 30. So the angle of incidence here is 30 now. Is this less than critical angle? Yeah. So now there should be refraction. And the refracted ray will be going away from the normal. Therefore, this must be greater than 30 degree. If the refraction angle is greater than 30 degree, therefore this angle must be less than 60. And this is the original direction. What is the original direction? B to A. So the angle of deviation is less than 60 degree. Correct? The original direction is this only, B to A. So this is nothing but angle of deviation. This is less than 60 degree. Okay? So now onwards, you have to only show the ray diagram for the required deviation. Now we are not going to discuss the application. Okay? Next case. There are two cases when there is no TIR. So here you have TIR everywhere. In all the examples we have discussed so far, one of the phases was causing TIR. There is exception in case of 30, 90, 60 degree prism. right? So this case there is TIR. Case 2, no TIR. With 30, 90 and 60 degree. So these are the two diagrams which will show no TIR. ABC. Now let us say you make the ray enter the prism from face AB. Right? What is the angle of incidence now? What is the angle of incidence? Yes, Adya. Adya, right? What is the angle of incidence here? Huh? Third, yeah? 60 is the angle of incidence. 30. This is 30. Why 30? Because this is 60. What is the angle of incidence? 30. So will it suffer refraction or TIR? Refraction, because this is less than critical angle. So now refraction it will go away from the norm. So there is no TIR now in this case. So no TIR case, right? So there is one more case, no TIR. In this case, now the ray enters from face AC. This also no TIR. Correct? This is 90. This is 60. This is 30. Therefore, this also no TIR. So there are two cases when the ray enters the prism from side AB or face AB, and when the ray enters from side AC, making angle of incidence 0 yahan pe. So on the face AB, now the angle of incidence is 30, 30 in both cases, and therefore there is no TIR. No TIR. Here also no TIR. No TIR. ठीक है. ठीक है ना? ये वाला केस भी एंगल ऑफ इंसिडेंस 30 मिल रहा है अपने. Now there is an exception. Okay. Fourth case is exception. On face AC, there is one case for which TIR will take place. What is that exception? नहीं एंगल नहीं चेंज करना, सेम. हाँ, लेकिन the ray is incident in a certain region which we'll discuss.
At the bottom. So
Yes.
we see 60 degrees will be the angle of incidence.
A, B, C. Now we are using 30-60 prism. Now what is the exception? Look here. When a perpendicular is drawn from the vertex B, okay, let's draw perpendicular. right? What is the exception? When the perpendicular is drawn from vertex B on AC, and if the ray falls within this region, okay, from the base to the foot of the perpendicular from B, as long as the ray falls within this region, or ray enters the prism from here. Now look here. This is 60, this is 90, this becomes 40. So this becomes 60. Now it will suffer DIF. So this is now 30. This is 60. So here you have DIF. Now it goes. This is refraction. Okay, so the only exception is when the ray enters from side AC near the base. How near? Draw a perpendicular from B to AC within that. तब TIR होगा बेस पे. ठीक है? ठीक है ना? So this is how it is. So this is 120 और ये वाला फिर से 30 बनेगा तुम्हारा क्योंकि ये 60 है, ये 90 है, ये तुम्हारा 30 बनेगा. ठीक है? So this is very simple. Once you understand the logic, it's all about angle of incidence, which will decide. Critical angle से ज्यादा है तो TIR, critical angle से कम है तो refraction. बस. ये सिंपल ज्योमेट्री से तुम एंगल निकाल सकते हो. नॉर्मल का यूज होता है. कैसे निकलेगा एंगल? पॉइंट ऑफ इंसिडेंस पे नॉर्मल ड्रॉ करो, देन अप्लाई एंगल सम प्रॉपर्टी. ठीक है? इट इज द एप्लीकेशन ऑफ एंगल सम प्रॉपर्टी. So with this we have we completed everything? Yes, we have completed all cases of reflecting prism. PIR by reflecting prism. All the cases we have completed. Okay, so now we'll do questions. Okay, now some consequences, just like some consequences of refraction. Let's discuss some consequences of TIR. Right? So there are some 5 consequences. First consequence is phenomena of mirage. Now, how many of you are familiar with mirage? Whole class is familiar with mirage. Okay, what is it?
And it's the thing on the desert.
Yes.
So, illusion.
So mirage is illusion. Mirage. Yes, it is an optical illusion. Right? It's an optical illusion. Has anybody witnessed it?
Yes.
So when you go down the highway on a sunny day, and if you're watching the road, let's say if you're fortunate, you're driving on when you're driving on a straight road, very far away, the road, you feel that you're going to enter water from the far, and it's like this.
Yeah, it's
And when you go near, it's again road.
like move.
Yes. Okay. So it feels like the some air is coming away from
It's like wetness.
Now let's see how it happens.
Desert का तो होता है. Desert is the part of desert. There are things that point. This one is there are 3,000 the third नहीं वो तो रियल में खेला था.
हाँ
तो फिर रियल लाइफ में इंडिया मेरा स्टेट यूज करता है एक बंदा इंडिया में
So Milad, you must have studied in stories like when a voyager, क्या बोलेंगे? Somebody is traveling inside desert, right? So far away, he sees that there is some water body. How he feels there is a water body? Let us say. So yes, it's called what? Mrugchal, yes. It's in Hindi it is called Rig Malaysia. Correct. Same thing. They are referring to the same thing. Okay. That's all you.
Actually, मैं रियाज में बैठा हूँ क्या मेरा वीडियो देखा मैं क्यों बैठ गया यहाँ पे
So let us say this is the tree. ठीक है? ये तुम्हारा क्या sand है ना? Hot sand. What do you have? इसको क्या लगा? घोड़े को इतना मारा है ना उसका पीठ टूट गया. Okay, don't miss the point. अपने को क्या देखना है? इसको क्या दिख रहा है मालूम? इसको ये ट्री का शैडो दिख रहा है. ट्री का शैडो दिख रहा है. ये खुश हो गया. उसको दूर से क्या दिख रहा है? ट्री का शैडो दिख रहा है. अब इसको कैसे एक्सप्लेन करेंगे? देखो, हॉट सैंड है ना, तो एयर इन कांटेक्ट विथ हॉट सैंड, ये हॉट एयर है यहाँ पे, मतलब ये क्या हो जाएगी? एक्सपेंड होगी. और जो अपर लेयर ऑफ एयर है वो क्या होगा? कूल एयर. तो अपने पास दो लेयर ऑफ एयर है. ये क्या है? हॉट एयर. हॉट एयर, ये इट इज फॉर्मिंग अ रेयर मीडियम. और यहाँ पे क्या है? कूल एयर. Cool as in not cold. It is relatively colder than this. समझ में आया? The air in contact with the hot sand is expanded, whereas the air which is upper is not so hot. So it is forming a denser layer. So it is denser. ठीक है? उसको थोड़ा और नीचे बनाओ. मतलब ये पास में होगा ना इसके. ये पास में होगा ऐसे. ये हॉट एयर मतलब ठीक है. अब देखो, अब हो क्या रहा है इसको? एट अ सर्टेन डिस्टेंस, यहां से जो रेज आ रही है, यहां से जो रेज आएगी, एट अ सर्टेन डिस्टेंस this will be angle of incidence will be greater than critical angle. तब क्या होगा? It suffers CIR here. Denser से rarer में जा रहा है. At a certain distance of approach, it will make a TIR. तो उसको क्या दिखेगा? ये कहां से आ रहा है? यहाँ से आ रहा है.
And you think it's a reflection of.
He thinks that yeah, it is the reflection. There must be some water body. समझ आया? ऐसे हो रहा है. This condition, denser and rarer medium are getting formed, and it satisfies TIR. इसके वजह से हो रहा है यार. जैसे ही वो आ गया है, एंगल चेंज हो गया. तो एंगल चेंज हो गया तो पेड़ गायब. ठीक है? तो ये है ऑप्टिकल इल्यूजन. सो हाँ, देखो बहुत प्रेशर आ गया. ओके, जल्दी आ. हाँ, यस सर. ओके, ठीक. Universe listens to whatever you say. Avoid negativity. बैंक है बैंक. Hot बैंक है universe. समझ आया? तो stay positive. Always stay positive.
सर ये कोई मेरा फ्रेंड लेकिन ऐसा वो कोई बात नहीं
मेरा भी be positive है.
मैं बेटा भी
हाँ, good. Yeah, buddies. Okay. तो ये हो गया हमारा फिनोमेना ऑफ मिरर्स. ठीक है? ये जो कॉन्सिक्वेंसेस दिए हैं ना, इसमें अगर तुम सोचोगे, इट्स रियली इंटरेस्टिंग. व्हाट इज नेक्स्ट? empty test tube placed in water. Okay, water beaker with the mouth outside water surface shines like a mirror when seen at certain angle.
यस
ये भी होगा क्योंकि टेस्ट ट्यूब को तुम क्या करो, टेस्ट ट्यूब के अंदर क्या है? एयर. ये कौन सा सिचुएशन बोल रहे हैं? सेकंड बोलो. ये तुम घर में देख सकते हो. ग्लास रख लो, टेस्ट ट्यूब की बजाय ग्लास ले लो, ट्रांसपेरेंट ग्लास ले लो. सेकंड केस में तुम एक यहाँ पे बकेट ले लो. ठीक है? बकेट में वाटर है और यहाँ पे तुमने एक टेस्ट ट्यूब ले लिया. ठीक है? यहां से तुम देख रहे हो. क्या कर दिया तुमने? इसको वाटर में रख लिया. ठीक है? एट सर्टेन एंगल अब तुम जब यहां से देख रहे हो तो रिफ्लेक्ट हो जाएगा. एट सर्टेन एंगल दिस इज एयर. तो बाहर डेंसर है, बाहर डेंसर है और अंदर क्या है? एयर है. हाँ, ठीक है? अब तुम कहीं से देख रहे हो इसको, टेस्ट ट्यूब को तुमने ऐसे ऐसे किया तो बाहर की सरफेस से क्या हो जाएगा? TIR हो जाएगा. I mean, let's take the observer this side. यहाँ, ठीक है ना? यहाँ से देख रहा हूँ. ये साइड से देखें. तो फॉर सर्टेन ओरिएंटेशन टेंसर से रेयर में जब आएगी ना तो ये मिरर हो जाएगा. मिरर कहाँ पे देखेगा? डेंसर से रेयर कंडीशन फॉर्म हो रही ना. यहाँ पे दो मीडियम बन रहा है, ये रेयर है और ये डेंस है. तो किसी ओरिएंटेशन पे टेस्ट ट्यूब के TIR होगा एंड टेस्ट ट्यूब विल अपीयर लाइक मिरर. ठीक है? ये तुम घर में ट्राई करके देखो. ठीक है? तोड़ मत देना, नहीं मार खाओगे. टेस्ट ट्यूब नहीं है, ग्लास लेके करना. ग्लास और बकेट उससे होना चाहिए. ठीक है? That's it. Similarly, a crack in a glass vessel often shines like a mirror. तुमने देखा है? कांच के अंदर क्रैक आया हुआ है तो वो चमकता है कहीं कहीं पे. ठीक है? You can very easily distinguish. This is the broken area. तो होता क्या है? जो क्रैक है, ठीक है, तुम्हें लगता है वो जुड़ा हुआ है, बट देयर इज अ गैप. उसमें क्या बचा है? एयर. ठीक है ना? तो एयर, हाँ, सो एयर और ग्लास का दो मीडियम बन गया, है ना? हाँ, तो इससे वो चमकता है, एक सर्टेन एंगल पे चमकता है. तो क्रैक इज विजिबल लाइक अ सिल्वर शाइन. ठीक है? ये हो गया. दो मीडियम होने चाहिए, डेंसर रेयर.
ऑप्टिकल फाइबर.
हाँ, मैं बताता हूँ. ठीक है? Piece of diamond sparkles when viewed from certain direction. डायमंड का क्या होता है? देखो, अभी हार्डेस्ट सब्सटेंस है, उसका क्रिटिकल एंगल सबसे छोटा है ना? तो डायमंड को क्या करते हैं? कट और पॉलिश करते हैं. डायमंड के जो सर्फेसेस हैं, इट्स अ स्किल. पीपल आर ट्रेन्ड इन दैट, कटिंग एंड पॉलिशिंग डायमंड. तो हर सर्फेस कैसा बनता है? एक बार लाइट डायमंड के अंदर घुसी तो उसके सरफेसेस ऐसे डिजाइन है कि हर सरफेस से टीआईआर सफर करता है, तो अंदर ही अंदर लाइट घूमते रहती है, देन इट बिगिंस टू ग्लिटर, ठीक है, स्पार्कल। तो इसलिए होता है क्योंकि एक बार लाइट डायमंड के अंदर घुस गई तो जल्दी बाहर नहीं निकलेगी, क्योंकि उसके सरफेस की पॉलिशिंग और कटिंग ऐसे की है, इट बिगिंस टू स्पार्क, ठीक है। सो दैट्स अबाउट स्पार्कलिंग और डायमंड। देन ऑप्टिकल फाइबर, किसने किसने सुना है ऑप्टिकल फाइबर? देखा किसने किसने?
सुना है।
सबने देखा है। डेकोरेटिव लैंप देखा है तुमने?
डेकोरेटिव
डेकोरेटिव लैंप्स, ऑप्टिकल फाइबर स्ट्रैंड्स ऐसे आते हैं और उसके टिप पे लाइट कलर्स होते हैं अलग अलग, वही फाइबर फाइबर ऑप्टिक स्ट्रैंड है। तुम्हारे घर के अंदर है फाइबर ऑप्टिक केबल, वाईफाई सबके पास है, कौन सा केबल आता है उसको कनेक्ट क्या होता है? फाइबर है ना, बोलते हो कि नहीं डेली? टुडे यू आर लिविंग ऑन फाइबर, सबके घर में है ऑलरेडी फाइबर ऑप्टिक केबल, ठीक है। आजकल जो भी कम्युनिकेशन हो रहा है किस पे हो रहा है? फाइबर ऑप्टिक केबल पे हो रहा है। और वो कैसे होता है देखो, वाटर पाइप सबको पता है, वाटर पाइप, वाटर पाइप जहां जहां मुड़ता है वाटर फ्लो अकॉर्डिंगली मुड़ जाता है, ठीक है। अब लाइट को हम मोड़ सकते हैं, वी कैन कैरी लाइट इनसाइड ऑप्टिक फाइबर, light otherwise travels in a straight line, but we can force the light to travel and bend as the optical fiber is bending. So it's a conduit to carry light. It's a light pipe, you can say. Just like water can flow as per the direction of pipe, optic fiber में light flows as per the fiber optic is turning. Okay, तो देखो कैसे होता है. Let us say this is fiber optic. ये bend है, light ऐसे ऐसे travel करेगी क्या? Can light ever travel like this? No. But all of you have seen that decorative lamp. डेकोरेटिव लैंप में कैसे ऐसे यहाँ स्टेम पे यहाँ पे लाइट ग्लो किया और वो कलर का लाइट वो फाइबर के टिप पे दिखता है तुमको, ठीक है, एज इफ द लाइट इज कमिंग आउट ऑफ द पाइप। तो कैसे होता है? ये जो फाइबर ऑप्टिक है इट कंसिस्ट ऑफ टू थिंग्स। एक तो उसका कोर है जो इनर साइड है, इनर कोर इज मेड अप ऑफ ग्लास, ठीक है, इनर कोर इज ग्लास फाइबर। अब फाइबरस ग्लास कैसा फ्लेक्सिबल है, क्योंकि ग्लास ब्रिटल होता है, जो विंडो में ये ब्रिटल, बट फाइबरस होगा तो यू कैन बेंड द ग्लास लाइक ए पेपर। तुम्हारे घर में जो फाइबर ऑप्टिक आता है देखो, ट्विस्ट करते हैं कुछ नहीं होता, लाइट फिर भी आती है उसके अंदर से, बिकॉज साइज ऑफ लाइट इज एंगस्ट्रॉम 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻10 billionth part of a meter. It's so thin. Wavelength क्या होता है लाइट का? पढ़ा है आपने? Wavelength is expressed in angstrom. So it is so small in dimension. 8000 angstrom सबसे बड़ा वाला. So small in dimension. तो अब जो हमको दिख रहा है आंख से उसका डायमेंशन लाइट से तो बहुत बड़ा ही हो गया। फाइबर ऑप्टिक तो दिखता है ना, तो लाइट का डायमेंशन इससे छोटा है। और होता क्या देखो, ये जो कोर है, कोर, उसका रिफ्रैक्टिव इंडेक्स समझे म्यू जी है, और उसको जो क्लैडिंग बोलते हैं बाहर का, there is a coating just like this wire, inside has a copper wire and outside it has a insulation covering. तो इसका जो रिफ्रैक्टिव इंडेक्स है समझो म्यू सी है, so mu g is greater than mu c. There is a difference in the refractive index of the material which is outside the core. So now once the light enters here, let's say light enters here, let us say the light enters here, ठीक है, तो यहाँ पे क्या है, everywhere you have two surfaces, right, throughout. What do you have? Two surfaces. So when the light enters here, it is made to suffer TIR. This is how it suffers TIR, and then the light can, you can carry light like a water in a pipe. तो तुम्हारे मॉडल में वो फाइबर ऑप्टिक घूम के आता है. So this is how it comes. ठीक है? So what happens? Electrical signal को there is a opto electronic device, optoelectronic converter. पहले वो electric signal को optical signal पे convert करता है. It is transmitted, and again when it reaches modem, the optical signal is converted back into electrical signal. ये सब हो रहा है, and we are all using it. ठीक है?
ये क्यों यूज करें इलेक्ट्रिसिटी
Electricity noise catch करता है, ये noise नहीं catch कर सकता. It is optical signal, and it travels at the speed of light. जो तुम्हारा वायर है उसका जो रेजिस्टेंस है, इसमें इसका रेजिस्टेंस कुछ नहीं है, प्लस सिग्नल लॉस इज लेस. दैट्स व्हाई ऑल द कैरियर्स, द CB cable under sea, we have laid fibers under the sea. The internet connection between India, US, throughout the globe is under fiber optics. Satellite connections are not that reliable. There is a delay. But fiber optic, that is why this broadband revolution is taking place everywhere. और टेलीविजन का सिग्नल कैसे आता है? डिश पे आता है, वो नहीं चलता, लेकिन तुम्हारा इंटरनेट चलता है फर्स्ट क्लास, फ्लॉलेस, बिकॉज इट इज कमिंग ऑन फाइबर, डजंट कैच नॉइस. हाँ, अभी लाइटनिंग होगा, टीवी का सिग्नल गया, इसमें कुछ नहीं होगा, इंटरनेट चलते रहते. गेम्स खेलूंगा. ओके, अच्छा ये तो हो गया डेटा एंड वॉइस एप्लीकेशन. दूसरा देखो मेडिकल एप्लीकेशन. पहले समझो उनको ऑपरेशन करना है, ठीक है, बड़ा कट मारते थे पेशेंट को, डॉक्टर ओपन कर दिया, इंटरनल ऑर्गन्स बाहर, ऑपरेट किया, ठीक किया, बाद में उसको स्टिच किया. हील होने के लिए 2 महीना लगता था, बड़ा कट लगता था
छोटा सा
सर्जरी में. अभी क्या करते हैं? 3 होल करते हैं, 3 होल. समझो गॉल ब्लैडर स्टोन निकाल रहे हैं, 3 होल करेगा. ये लाइट सोर्स हो जाता है फाइबर ऑप्टिक. पेशेंट के अंदर टॉर्च तो नहीं डाल सकते ना, फिर कट करना पड़ेगा. तो फाइबर ऑप्टिक एक्ट्स एज फ्लेक्सिबल सोर्स ऑफ लाइट. वो एक होल में डाल दिया, दूसरे होल में कैमरा, तीसरे होल में सर्जिकल इंस्ट्रूमेंट, और मॉनिटर में देखते सर्जरी होती इंटरनल ऑर्गन की. समझ आया? सो नाउ द डैमेज टू द पेशेंट इज सो लेस that he can be sent back home in just 2 days, and in some cases same day. तो जो पहले हील होने के लिए, इन्फ्लेमेशन हील होने के लिए मंथ्स लगते थे, now the surgery can be completed in a day, and the recovery is so fast. है ना? ये है wonder. And who invented this? An Indian. Okay? ये किसी को पता ही नहीं, ठीक है ना? फाइबर ऑप्टिक्स पे इनोवेशन बाद में बहुत हुआ, लेकिन बहुत सारा फंडामेंटल चीजें हम लोग ने किया है. But our people are kept under the wraps by these Westerners. That's why I don't like them so much. Okay? All right. समझ में आया फाइबर ऑप्टिक्स? तो ये तुमको ऐसे कॉन्सिक्वेंस जो छोटी-छोटी चीजें दी है ना, ये है डेली लाइफ एप्लीकेशन. ठीक है? चलो, with this we have completed this chapter. Now we'll do questions. Very few numericals in this chapter. You can count 4, 5, 6. Not much. But lots of ray diagrams. What is it? Lots of ray diagrams. So come on, page number. So review questions by your direct question. These are mostly theory that you can do yourself. Come to class work review. So numerical class work. So you have page number 76. Page 76. Okay, UT volume page 76. Everybody open the volume. What is given here? speed of light in air is given. Calculate the speed of light in glass. And refractive index of glass is given. So what is given here? Given. This is what is given. So you have to now remember all the refractive index formulas. Okay? The solution. So how do you express refractive index of glass? What is the formula for absolute refractive index of glass? C by Vg. Formula for absolute refractive index of glass is in terms of ratio of speeds of light. So therefore, what is Vg? (1.5). Yes, 3 by 1.5. What is it? 30 by 15. So this will be straight application of formula. So very simple numericals. Next is question 2. What is given? A monochromatic ray of light strikes the surface of transmitter angle of incidence. So given, what is given? I is equal to 60 degrees. R is equal to 45 degrees. What is the refractive index of the medium? You have to find the refractive index of the medium. Sin I by sin R. Good. So mu is equal to. Who said that? Okay. So sin I by sin R. So this is sin 60 divided by sin 45.
Sir,
And the values are given in the question. Sin 60. In this question, the values are given. Otherwise, you can do sin 60 root 3 by 2 and sin 45 is 1 by root 2. Okay. So you can do that, but here it is given in the question itself. It is, so make a correction, it is 0.866, not 0.866. And 0.707.
0.866.
Yes. 0.86. 0.866. Less than 1. No? Sign value cannot be more than 1. It is 0.866. So in volume, just correct it. It is given 0.866. So this should give you the answer. So it will be, answer should be greater than 1 because denominator is smaller than numerator. ठीक है 1.224. कैसे किया कैलकुलेटर?
मैंने ये नहीं कैलकुलेट किया वो पहले।
अच्छा 1.22 वो वाला ज्यादा इजी रूट 3 का वैल्यू पता है रूट 2 का वैल्यू पता है आ जाता पड़। इसको ऑल्टरनेटली कैसे कर सकते हैं मैं बताता हूँ बट ये क्वेश्चन में दिया है ना तो ये आंसर आ जाएगा ऑल्टरनेटली इसको कैसे कर सकते हो इसका ऑल्टरनेट सोल्यूशन what is sin 60 root 3 by 2 and what is sin 45 1 by root 2 ठीक है so 1 by 2 is 0.5 1.3 is 1.7 1.71 या 1.73
1.73
into 1.41, right?
414.
732.
Yes, sir.
तो ये मल्टी, दिस इज मोर इजियर. 1/2 is 0.5. तो यहाँ पे डिवीजन नहीं करना है, यहाँ पे तुमको मल्टीप्लाई करना है. वो भी कर सकते हो. अगर ये तीसरा मल्टीप्लिकेशन नहीं करना है ना, तो देखो एक काम और कर सकते हो, इसको डिवाइड बाय 2 रख लो. ठीक है, तो कोई भी एक डिवीजन कर दो, तो 0.8 then 6 into 1.414, ये दो मल्टीप्लिकेशन आ जाएगा तुम्हें. ठीक है ना, 3 करने में 2 कर लो, आंसर आ जाएगा. ओके, shall we go to the next question? चलो क्वेश्चन 3 में क्या करना है? शिफ्ट निकालना है, शिफ्ट.
D, the shift equals to D into 1 minus 1.
Yes, d into
1 by
1 by 1 mu m. तो d कितना दिया है? रियल डेप्थ इज 12. 1 minus 1 by 4 by 3, मतलब ये हो जाएगा 3 by 4. So this will be 12 by 4. This is 3 centimeter. Shift to forward. Direct formula based question है.
If it comes to calculate the current, then we have to calculate the fixed and
Directly raised लिखा है ना उसमें. By what height the coin appears to be raised. हाँ, तो फिर small d equal to capital D divided by mu. हाँ. ठीक है. Now question 4. What is question 4? A ray of incident light at an angle 72 degree. So this is an equilateral prism. So what is given? I is equal to 72. Delta is equal to 45. A is equal to 60 degree for equilateral prism. So you have to find angle of emergence. So what is the solution? We know that I plus E is equal to delta plus A. This is the formula. Either I plus E or you first have written I1 plus I2. So I2 becomes angle of emergence, right? So you have to find E. Therefore, E is equal to delta plus A minus I. How much is this? Okay. So angle of emergence is you can take I1, I2 also. This I1, this is I2 equal to. I2 is angle of emergence, right? I2 or E, sometimes it is used as E. Can I erase third? Is everybody with me?
Yes.
Any explanation needed? Question number 5. So this is a question on minimum deviation. So what is minimum deviation?
I equals to E.
2I minus A. This is what is the formula. Minimum deviation formula is delta m is equal to 2i minus a, right? So this is the formula. What do you have to get? You have to find I. Therefore, what is I? Delta m plus a divided by 2. So what is given here? Minimum deviation 36 degrees. Equilateral prism. So A is 60 divided by 2. So 96 by 2. 48 degrees. This is 48 degrees. Do question 6 yourself.
Yeah. Very.
No help to be extended to your friends. Question 6 to be done by self. I'll stand at the well, watch everybody. Some neck breaking moments. It's they got ESL just do this question possible. 4-5 लिखा क्या लिखा? एक लोग पहले 4-5 लिख लो. Done. Who has done question 6? Only one hand raised up. Okay. Okay. What happened? People keep on. What happened? People think, yeah. No, it is fine. देखिए हेल्प कर रहा है इसको पंचिंग बैग मार्क मत रखो Mark, you don't help him. He can do. I know he's capable. Two questions from homework. Those who have done question 6. आगे आंसर क्वेश्चंस तो क्या आ रहा है इतना टाइम लगे नहीं है क्वेश्चन पढ़ के आंसर आ जाएगा क्या हुआ 3 hands very good
Which question level?
give the question
Sir, or is there any solve?
no that's what I told you there's no need to solve it
Okay, sir. Okay, sir.
exactly this was you got it finally this question में कुछ solve नहीं करना है
बस ऐसे टोटल निकाल.
क्या सर
0.7.
मीडियम से जो है भाई ओके ये फॉर्मूला लगेगा refractive index of water with respect to air is equal to 1 upon refractive index of air with respect to water. Therefore, 4/3. What is the answer?
0.7.
3/4, which is 0.75. That's the reciprocal. That's the reciprocal. ऐसे क्वेश्चन आते हैं एग्जाम में तुम्हें लगेगा बहुत डिफिकल्ट है ऐसे आते हैं एग्जाम में अभी सिंपल लग रहा है बहुत सारे महारथी लोग को ये भी नहीं आता इट इज नॉट अ क्वेश्चन Okay, let's discuss application type now. Okay, everybody. Application type. This is on page number 77. Okay, everybody will take turn now, okay? And I'll decide who will answer.
On the board.
Everybody, no, in your notebook, everybody, question one, everybody, fast.
Yes, sir.
1 minute only. That diagram is okay. Once done, you have to raise your notebook like this. Is it time?
Yes.
Time for me to go. Okay. Take it as homework. Next class we discuss. This time, just feel like 1.5 hours.
Sir, मला
Homework में करके रहो. We'll discuss. And one last thing. What is homework? Whatever not done in class, even if it is classwork, becomes homework. Okay? You understand? Try that. Okay, try that. Your question हमने नहीं किया वो homework. And we will discuss in difficulty.
हमारा कई लोगों का पेपर इतना बहुत अच्छा मार्क्स दिया तो क्या प्रॉब्लम है केमिस्ट्री 12-13 मार्क्स देने के लिए इधर आती है तो तुम घर में बैठ के भी दे सकते थे विश्रुत तुमको तो टेस्ट देने का ही है बच्ची आज का आदित्य तुम्हारा भी वैसे ही काम होना है मस्ती वगैरह जो करने का नहीं पढ़ने का नहीं इसमें अफ्रीका और जिसने भी लिया नहीं पेपर प्लीज दिया करो तुम्हारा अवेलेबिलिटी देख के ग्रुप को
Yes. Yeah, right. 20% ऐसे 20 राइट है फर्स्ट चैप्टर क्या परसेंट आएगा
अरे यार तुमको नहीं किसी
परसेंट आएगा फर्स्ट टेस्ट क्या किया तुम लोगों ने फर्स्ट टेस्ट अभी दिया तुम लोग Not to pure non-veg ना omnivorous हो जाएगा यार 500 लाख बहुत Alfonso मामी वाला लड़की को बोलेगा नहीं मैं सब्जी रोटी लीजिए मैं सवर पहले एक बार जीत रही थी जीत गया मैं जीती भाई हम लोग अगर तक मैच कर रहा है चैट जीपीटी एक बार तो मैं बोले बहुत सिंपल समझता चैट जीपीटी उसके उसके लिए गलत आंसर दिया मेरे लिए करेक्ट आंसर दिया हाँ जो मेरे पास आंसर और मेरा करेक्ट आंसर है उससे गलत
भाई पता है कल मैंने ये बोल